Our project is about analysis of groundwater quality for drinking water purpose using GIS techniques. These are the methodology we are conducting to complete the project. Introduction. Groundwater. Groundwater is water that is found underground in the cracks and space in soil, sand and rocks. The speed of groundwater flows depends on the size of spaces in the soil or rocks and how well the spaces are connected. Pollution. The word pollution has been taken from the Latin word pollution, meaning defilement. Defilement means dirty. In 1966, the National Research Committee gave a report in which pollution is defined as an undesirable change in physical, chemical or biological character of air, land and water that may or will harmful affect human lives or that of desirable species. Literature review. Assessment of groundwater quality in Gaza Strip, Palestine using GIS mapping. Aim. The aquifer of Gaza is extremely susceptible to surface derived contamination because of the high permeability of sand and gravel that compose the soil profile of Gaza. No groundwater in Gaza meets all our drinking water standard and is therefore not safe for human consumption. Procedure. Chloride is elevated in the coastal areas as such a result of seawater intrusions, and in the eastern areas as a result of upcoming and over pumping areas naturally contaminated with high concentrated of F-, Ca2+, Mg2+, and SO4 occurs as an expected due to the underlying soil chemistry, geology and hydrogeology. Conclusion of literature review. The GIS BRAS zoning of groundwater quality map may be used as a guideline for predicting the groundwater quality to new areas. The present study provides a guideline for solving water quality problem in Kunnur Taluk. Objective is to conduct a field test on groundwater polluted areas, to collect the necessary water sample in the study areas, to analyze the chemical and physical properties of the water sample. Interruption of groundwater sustainability for drinking purpose using geographical information system. Scope. Analyze the groundwater quality in the study area. Creation of map on groundwater quality using GIS. Methodology. Field test, sample collections, laboratory test. Simultaneously GIS, sample location, GPS, geoprocessing, base map, and go on to analyze interruption using GIS. Indian standard for physical and chemical parameters which are provided in these tabulations. WHO stands for physical and chemical parameters. These are the study areas we are go through and collect the sample and test it for our project. A map we are collected the water sample. Physical characters. Color, dissolved organ matters for decaying vegetations or sample inorganic materials such as colored soil, etc. Taste and odor. The dissolved organic material or inorganic salt or the dissolved gases may impart taste and odor to the water, which generally occurs together. Turbidity. If a large amount of suspended matter such as clay, silt or some other finely divided organic materials is presented in water. Temperature. Testing the temperature of water has usually no practical significance. Electrical conductivity. Specific conductivity yields measures of water capacity, no convey an electric current, and the ionic strength of water sample vitally affects the specific conductance. Total dissolved solid. Total dissolved solid is a term applied to the residual remaining in a weight dish after the sample has been passed through a standard fiber glasses filter and dried to a constant mass at 103 to 105 degrees Celsius or 179 to 181 degrees Celsius. Physical test. Measure of turbidity principle. Apparatus required. Sample tubes. The sample tubes should be of clear and colorless glass. Procedure. Turbidity meter calibration follows the manufacturer operating instrument, measures the standard on turbidity meter covering the range of interest. Procedure. Temperature was measured with the thermometer immersed directly in the water body after a period of time sufficient to permit constant reading. Result. Groundwater quality gives a clear picture about the usability of water from a different purpose. The standard qualities for drinking water has been specified by Indian standard. Color, odor, turbidity, temperature, EC and TDS are mentioned in the tabulation. You can refer in this. Chemical characteristics. pH value of water. The pH value of water should be neutral, not should be basic or not should be acid. Normal natural water is generally between 6 to 8. Hardness of water. The hardness of water it is usually caused by the presence of calcium and magnesium salt present in the water. Chloride contents are generally present in water in the form of sodium chloride and may be due to leaching of marine sedimentation deposit, pollution from the seawater. Fluoride. Traces of fluoride are present in many waters. Higher concentration are often associated with the underground source. In seawater, a total fluoride concentration of 1.3 milligram per liter has been reported. Calcium is a major constituent of various types of rocks. It is one of the most important and common constitution present in the natural water, ranging from 0 to several hundred milligram per liter. Calcium is a cause for hardness in water and it incrustation in boilers. Magnesium is a common constitution in natural water. Magnesium salt are important contribution to the hardness of water, which breaks down when heat forming scale in its body. Sulfate. The major physiological effect result from the indigestion of a large amount of sulfate or dehydration and gastrointestinal irrigation. Chemical test procedure. Measure of pH apparatus. pH meter. Reagent requirement. Water sample. Procedure. Electroconfusion. Other commonly being a mercury chloride and mercury electrolyte. The cell potential is the linear can be calibrated to read the H+ ion concentration. Measurement of total hardness. Apparatus required. Burette, pipette, conical flask, standard flask and funnel. Reagent requirement. Buffer solution of ammonia, aerochrome black tea indicator, standard EDTA solution of 0.01. Procedure. Take 20 ml of water in the conical flask and add 1.2 mg buffer solution of ammonium and add 2 drops of aerochrome black tea and titrate with standard EDTA, that means 0.01, till wine red color changes to blue. Note down the value or volume of EDTA required. Measurement of chloride. Apparatus required. Burette, pipette, conical flask, wash bar. Procedure. Take 20 ml of water as above total hardness procedure should be followed in these conditions. but 5 drops of indicator titration against AgNO3 taken in the burette with a permanent reddish brown color appears. The filtration is repeated for the concurrent value. Measurement of sulfate. Reagent required. Conditioning reagent. Mix 50 ml glycerol with the solution. Contain 30 ml. Procedure. Formation of barium sulfate. Turbidity. Measures 100 ml sample or a suitable aliquot made up to 100 ml into 250 ml in a conical flask. Measurement of fluoride. Apparatus required. Nasal tube 100 ml capacity. Procedure. Take 100 ml of clean sample and a series of dilution of standard sodium fluoride solution in 100 ml of distilled water in a nasal tube and add 5 ml of zirconium alizarin reagent to each. Measurement of sodium. Apparatus required. Procedure. A flammable photometer measures photoelectrical the intensity of color imparted to the flame of microtype burner where the sample is introduced into the flame under careful standardized conditions. Measurement of iron. Reagent required. Ferrous ammonium sulfate hexahydrate. Procedure. Dissolved 0.0722 grams of ferrous ammonium sulfate. Prepare a standard solution from 0 to 468 ppm respectively, diluting 0, 2, 4, 6 and 8 ml of the 100 ppm stock solution into 5 separate 100 ml volume flasks. Clean and dry a set of cuvette. Label the cuvette 0 ppm, 2 ppm and 4, 6, 8 ppm. Fill each cuvette with the approximate solution. Measurement of nitrate. Procedure. Fill the sample bottle with sample water. Use glove if drawing the sample by hand, resin and fill one test tube to 2.5 ml. Line with water from the sample bottle. Measurement of magnesium. Reagent required. Standard EDTA solution of 0.01 chrome black tea indicator. Procedure. Take suitable liquid of solution of material exactly the the same as expected to contain approximately 10 to 30 mg of calcium and magnesium combined oxides in a 500 ml conical flask. Refer this table for the chemical parameter and analyze the chemical parameters. The chemical parameters will change for each and every areas. Geographical information system. Geographical information system, which is called as a GIS, is a computerized based information system used to digital representation and analyze the geographic features present on the Earth surface and the events that take place on it. Referencing. The procedure for base map preparation in ArcGIS is mentioned below. Step 1. Create the layer. Step 2. Above the topo sheet. Step 3. Using the option add control point. Step 4. Validate control point and fix it. Topo sheet. Step 5. Topo sheet is rectified and placing fourth control point on the topo sheet. Step 6. Link table with GCP. Step 7. Open Arc catalog. Step 8. Add the shape file to the layer. Step 9. On the editor toolbar, click start editing the boundaries of the topo sheet. The pH value chemical details will be mentioned in this graph. TDS of GIS interpretations. Conclusion. From the result of groundwater sample analysis, it is seen that pH in all the locations were lies between 9.3 to 9.9 that all the conditions are good to use the water for the drinking. Reference: G. Raja and Venkatesan, Assessment of Groundwater Pollution. Base: Shomer, Sami, Abu Fraher, K. Sundara Kumar and T. Subramaniam. Thank you for watching this video. Bye.